In this presentation, we will learn how to create a node of a single linked list. So let's get started. First, we will recall what is self-referential structure. Self-referential structure is a structure which contains a pointer to a structure of the same type. And here is an example of a self-referential structure. I'm considering here the struct ABC as a structure which contains a pointer to the struct ABC only. That is why it is called self-referential structure. It is referring to itself. So I'm repeating the definition again, that self-referential structure is a structure which contains a pointer. This is the pointer which is pointing to the structure of the same type. We will use this self-referential structure for creating a node of the single linked list. So let's see how to create a node using self-referential structure. Here you can see this is the pictorial representation of a node, which consists of data as well as the link part. We have already seen that a node consists of data as well as the link part. This is how a node of a single linked list looks like. So it consists of a data as well as the link part. Basically, a node is nothing but the combination of two different types, right? Now, if I ask you how to combine two different types into a single type, then immediately you will get the answer. We can use structure to combine two different types into a single type. We name it with our own type. So the immediate answer for this is creating a structure, right? And here is how we will create a structure which represents the node. We'll call this structure as struct node, which consists of these two different types. The first is integer data. It could be any data. And let me tell you that the data type doesn't matter. It could be char, float, or any other data type. I'm using integer here for simplicity's sake. It could be any other data type as well. Now the second one is struct node star link. Now why this is struct node star link? Because this link is the pointer to some other node. And as I said, a node is nothing but a structure only. So this must be a pointer to a struct node. So link represents the pointer to struct node. That is why this must be struct node star link. Isn't this a self-referential structure? Right. This is a self-referential structure. So a node is nothing but a self-referential structure in C programming. Now, in general, a struct node looks like this. Here we could have multiple data, but there must be only one pointer. It should be well noted when we were talking about single linked list, then there only one link is allowed, but we could have multiple data. This is possible. Now, let's discuss how to create a node in C programming language. For this purpose, we have to include these two libraries, that is stdio.h and stdlib.h. Why these two libraries are required? The first one is obviously the mandatory one because it is representing the standard input-output. And here this library is required to call the malloc function, right? We will use malloc function to create memory for struct node because creating a structure is not sufficient. We have to allocate memory for it. That is why we need to call malloc function. Inside the main function, we will create one pointer head, which is the pointer to struct node only. That is, this pointer can access data as well as the link part of the node, right? And basically I call this pointer head because this is the pointer to the first node of the list which we will create later. Here in this presentation, I'm only talking about how to create a node of the list. So here I have declared a pointer which is the pointer to struct node and I have initialized this to null. So here is the pictorial representation of head which contains null. Now here in this line, I'm calling the malloc function to allocate memory for struct node. That means malloc is helping us to create a node. Okay. So here you can see a node is created, right? Because here I have passed in malloc size of struct node, which means the memory has been allocated for data as well as the link part. And after that, malloc will return a void pointer which can be typecasted to struct node star. But we can actually avoid this step also because in C programming language, it is not mandatory to typecast the void pointer. We can simply store that pointer without typecasting. But this is a good practice. You can avoid this also. There is no problem. Here I'm typecasting it. In the subsequent presentations, I'm not even going to typecast it. So here I'm typecasting it. You should remember that it is not mandatory. Here after typecasting, the pointer becomes a pointer to a struct node which can be stored within this head pointer. Basically, the address will be stored within head pointer. Here, I'm considering the address of this node as 1000, which is the base address, and this address will get stored within this head pointer. So head contains this address 1000. That means this head is now capable to access the struct node. Now how it will access? With the help of arrow operator, head can go inside the node, right? So with the help of our arrow operator, head is accessing the data and it is trying to initialize this data by 45. So here, this data will be replaced by 45. And after that, we can also access the link part, and I want to replace this by null. After this, I'm just calling this printf function to print the data on the screen, and obviously I'm using the head pointer to access the data, because there is only one way to access this node, and that is through head pointer. This is important to understand. Every time if you create a memory for the node, you must have a pointer which will store the address of that node. Because if you won't create the pointer which will have the address of the node, then there is no way to access the node. That is why a pointer is required to access that node. So the output of this program is definitely 45. Okay friends, this is it for now. Thank you for watching this presentation.